Welcome back to Made Up of Wires. We're decompiling Castlevania Symphony of the Night. Sorry with the long intro. I was trying to get YouTube working, and now it looks like it is. Okay. That's what we're doing. We're decompiling Castlevania Symphony of the Night and breaking things along the way. Doing what I can to break as much as I can. So, what does that mean? That means we're going through each of the files one by one on the Symphony of the Night disk, trying to recreate some C code that will compile to exactly what was on the disk, and then sharing it with everybody. You can go to soten.z.dev to learn more. It's going to be a little bit of a shorter stream today, but I'll talk about some of the things that I'm breaking and what we're going to do about it. As well as look at some of the Richter stuff. I do need to add Richter to this, and probably RTOP too. I don't think I ever went back and added RTOP. I didn't. The reverse keep. Okay, so I broke some things, and now I have to take responsibility for my actions. What did I break? Let's look at the functions report. First of all, I broke the workflow that generates this. Ooh. Second of all, I broke... I don't know how I did that, though. Let's look. How did I break that? Too much stuff on my desk. Canceling the music with... Pausing the music with my coffee. So, we have workflows that do CI for us, which is nice. And we were looking at the validate and report workflow. And along the way here, yeah, I got rid of this run entry. Not sure how that happened. I think I maybe added back in the publish reports and forgot the run key along the way. Sozu fixed that for me. Appreciate that. The other thing that happened was I left out the fix matchings. And I'm going to fix that in the make file because I prefer to do this in make rather than GitHub workflows. The problem I have with the GitHub workflow configuration is that there is no easy way to run it locally, and there might be tools now. But in the past there wasn't, and I've seen this happen in basically every CI system. Typically in a CI system, a good CI system won't even let you do this. It will make you go through some configured build tool. I mentioned before that I worked at a FANG for a long time, and our build system there, as part of the configuration for your package, you specified what your build tool was, and regardless of how you configured that, the build system or CI system would only use that as the entry point, and that's what you used as the entry point when you were building locally as well, and so everything went through that. I treat make like that entry point, and so I want everything to go through make, and it doesn't have to be make, it could be whatever build tool you choose. The point though is don't put arbitrary commands in your GitHub workflows, because as you build up your environment and all the other things that go into that, it becomes more and more unlikely that that's reproducible in a real environment. All right, so what I broke along the way was filtering out functions like this, where cutscene unknown 1 is definitely decompiled, but this is picking up the HD version of it. And we have a tool in here called fix oh, what was it called? Fix matchings. And the purpose of fix matchings is to do just that. So let's go find the function finder. And so we need to look at that one more time. So we do the 4 symbols, fix matchings, and then we can either do the function finder or duplicates, and we'll just have that as a step prior to we'll do that in prepare reports. So we'll do 4 symbols and then fix matchings. And that should be enough. Let's try it out. And we'll do function finder. Hey, Batty801. I don't know that I want to, do I? I feel like that's gonna get me in trouble. This is another issue, unrelated, and actually I should pop my stash because I have a fix for this. This actually is, I'll talk about it in a second. There's a tool that runs as part of the reports called Analyze Calls. And Analyze Calls goes through the disassembled code and tries to build a call graph. And there's some things that trip it up. Basically any JALR instruction, jump and link register. So when you look, in some cases when you dynamically are calling a function, you put its address in a register and then you call that address. And so that could be a dispatch table. It could be some function that you stick in a struct that's custom to that entity, for example. That happens quite a bit. In any of those cases, you may not know within the context of the function what function is actually being called. So you can't build a call graph on those. So there's some code in there to filter those out. B06 had a slightly different variation of that than we had seen before. And this script had been broken for so long that I had found a couple other ones when I made this change earlier. So let's get this running and make sure. What we want to see is that that cutscene 1, the cutscene unknown 1, no longer shows up there. And I don't recall how long this takes. I didn't think too long though. But maybe I'm wrong. There we go. Why did we... Oh, function finder looks for the duplicates as well. I should fix that too. All right, so in the reports, yep. So we don't have sen in here anymore, and cutscene unknown 1 is gone, and all of our new so the B06 import is in now. So we get all of our B06 functions in here. So if you go to that function table in GitHub now, you'll see all the B06 stuff that we've been working on. Not all of it, just the imported stuff. A bunch of these are actually done already. So the other thing I want to fix real quickly while I'm here is in Function Finder. We don't want to look at GH duplicates. We want to look at build. Build US reports. There's a lot of details to these that I don't know about. And obviously, I'm breaking them. It does look like that should work. Let's try it again. The other thing that this change did was make it very easy to rerun these things. So not only do you not have to reference the GitHub workflow, but I don't have to change the GitHub workflow. And obviously, I've made a mistake there before. I'll make one again. I don't like changing those. And so if I can have a clean single entry point there, that's what I want. And then I can change my makefile and rerun these as much as I want. Hey Joel, good to have you. Dizek, nice to have you back. And we'll get to some decompilation here shortly after I verify my fix. So we've been working on BO6. I'll talk a little bit about that before we go. We did the warp background brightness. That was a fun, just do it by hand type function. Some of these other ones we could probably do by hand too. Anything that's only a handful of characters likely is just setting some global data, or maybe doing some simple math. And so anything below 20 is probably a good candidate to see if you could do it by hand. The branches may or may not cause some problems, but if that's something that you find fun, those are good little puzzles to solve. We do have some bigger ones, obviously, to work on. Blink white should be pretty straightforward. Many of these I think we've done already. All right, that finished. And we're no longer getting that error because it's looking at the right place. So I'll get that in a PR later on. Let's see. I should have a pretty clean workspace. And what should we work on today? Let's find something a few thousand K in size. Something like the Bible trail might be interesting. We do have a reference for that. Yeah, so looking at jump and link, Dig Down Deep says how the number of branches. All of the instructions, branch not equal, branch equal. What else do we have? JL, JLR. It might just, for the PlayStation, might just be those 4 instructions. And branches aren't, oh, there's a JR as well, jump register. A lot of these heuristics were put in quite a while ago, when I think most of the people working on this were at least myself, less confident, less experienced in doing this. And so these kind of acted as heuristics for how difficult something might be. And if you're just getting into decompilation, these still might be good heuristics. So everything's going to have at least one branch, and that's going to be the JR instruction at the end, jump return. Sorry, JMP is the one that I mistook for the jump register. Is there anything else? The jump table, I think that used to be a more difficult problem as well, because we didn't export them with the jump table in the assembly file for the function that it was related to. So you had to go find it, and then you had to format it correctly to get into decomp.me. So these all acted as kind of a measure of how difficult that might be. Is that the case anymore? I don't think so. I don't necessarily think that these are good heuristics. A large function isn't necessarily difficult, and a small function isn't necessarily easy. And I've said that quite a bit. One of the hardest functions that I worked on was memmove. It's like 40 instructions, but getting the right C for those 40 instructions was pretty difficult. So let's do Bible Trail, and we'll see if that's similar. I'm guessing it's going to be very similar to the Rick version of it. I'll stay there for now. And we can look at the duplicates report actually and see how similar. These duplicates that exist are probably, yeah, so it's going to be exactly the same. Should I say exactly? It won't be exactly the same. Things like Richter versus player, grick versus gplayer, things like that will change. But whatever differences there are between Alucard and Richter, basically it looks like those same differences are going to exist in Boss Richter. This is probably going to be the only one of these that I do on the stream, because I don't think these are going to be very interesting. I think they're going to be copy-paste. And I need to find a decomp.me. I think they're going to be copy-paste. And I just don't think that's going to be the most interesting thing to look at. So let's do that first. Let's go find Richter's sub-weapon Bible Trail. What I would like if, and I haven't looked into how I might go about doing this, I can think of a couple ways, but when we do the duplicates report, the way we cluster things is basically the first function to be seen is the one that gets chosen as the best version of that function. And what I think would be better would, oh, sorry. I'm jumping around GitHub. What I think would be better is if we took the implementation that is the most similar to the other ones in the cluster. And so in this case, Richter's and Boss Richter's would probably be the same. And then Alucard's would be the one that is treated differently. So let's grab this implementation, and then we'll see what. Let's see how close it is. And yeah, it pretty much is the same thing. So we have some immediate differences here down on line 11. And that's the flags. So for flags, I'm going to get rid of those and replace them with the immediate value. that gives us a 15 difference. 15 is usually not, if this number is odd, it's always a multiple of 5, but if it's odd, that's usually a bad sign. Typically they're even. There's a few cases where they could be even, but or odd, but not in this case. So our draw mode, and then that's it. Everything else is the same. That's why I said I think a lot of these just will be very straightforward and not difficult at all. And that's how Doppelganger was too. Oh, is Bible Trail not here? I might be on the wrong... No, it is. Odd that it shows up here, but... So when I run the report targets, it mucks with the exported assembly, and there would be a couple ways to get around that, and I'm already appending to the symbol table, so maybe dumping the assembly to the build directory for the reports wouldn't be the worst idea there. But that built just fine. We're gonna make this an OVL export. And that one is that. So let's find a function that doesn't show up in the duplicates table. Let's find something about that same size. And see if we can get that done. Hey, Project Omega. Good to have you on YouTube. Thank you. Yo, Jefferson. Good to have you as well. So I want one. I want a function that doesn't have a symbol name associated with it yet, because that's likely to be unique. But then we're going to go over and look at the duplicates and see if so this is a duplicate as well. It's just not a nice name. I'm going to keep looking for these. So here we go. So this is something that is not at least 90% similar to one of the functions that we've already decompiled. Or it doesn't have to be decompiled. It's not 90% similar to any of the other functions that have been imported yet. So it would be nice, and I have an idea of where we might find it, but we should find Shaft's orb. That sounded worse out loud than it did in my head. I don't know what this function is yet, or what it's related to. I'm going to throw it in decomp.me, but then we'll go back and we'll look at who the callers are, and if we can get an idea yet of what that is. We do have a few. This looks very similar to that other one. So we have some entity extension that we don't know what it is yet. Sorry. There we go. Some animation frames. This looks very similar to the Bible trail function that we just did. So let's work on this a little, and then I think after this we'll go through and try to find the other interesting things about Richter that are different from player Richter or anybody else. So first I'm going to get this compiling, and then we'll clean up, and then we'll try to get a match. So 18. We have these illegal entries. This looks like it's probably pointing to a primitive. I'm going to do a couple things. Actually, no, primitive. It looks like it's pointing to another entity. I'm going to put the signature in the context and get a new decomp. I'm going to put this in the context as well. It's going to be an array of animation frames, not a single one. And we'll go from there. So there is it looks like actually it's looking at the next entity and grabbing the position X and position Y from that. So it's going to be something like this: self +1 pos X dot val. I know that because this is 84 away from this value. It might not be that. 84 is a suspicious number. 84 is 8C is the size of an entity. So when I see numbers in the 80s like that, I feel like they have to be around that size. We'll try that and see if that works. 28. Another one here. I'm going to do the same thing. Self +1 facing left. And if it doesn't work, that's fine. Why did that? Come on. There we go. So I might have to pull this out to a next. It also might be a it might be a pointer in the entity extension. We'll see. I'm going to do some cleanup now. So we're compiling, get rid of the go-tos, which are uncommon. This is going to be a destroy entity down here with a return. This is a ++ on whatever this timer is. Heading, I don't know if heading into the end is the right. Jefferson says heading into the end of the decomp journey. We're only, I'd say we were about 40% of the way done with the US version of the game. So if that's heading into the end, then yes. If not, then I think we have a ways to go. I don't want to keep this illegal, but I do want to fix it. So this is going to be a pre-increment, and my guess is that it's going to be inline, and we're going to take out the greater than equals and just say greater than hex 26, which is 38. We can get rid of all of those things. This destroy entity down here with a return up here. We're going to change that as well. It's going to be equals -1. And then throw the destroy entity up here with a return. Exit early. Do a step ++. Oh no, that's fine. There was a video game Esoterica did a video a couple months ago that said like we're almost done with decomp, and it was because we only included the overlays here that we've been working on. And so we had like just a handful. So imagine all these gray ones are gone, right? We only had a handful that were blue, and everything else was green. And it looked like, yeah, we're almost done. You know, we're kicking butt. But really, we had all these gray ones that we hadn't even started. And so I added those, I think it was back in June, just to provide a clear indication that we indeed are not done or close to done. It is going faster. Every time we get another overlay done, the next one is faster. The bosses are kind of the exception, because they are much more unique than other overlays. But even those, I think, are going a bit faster as well. I was wrong about, I saw 8C and my head was thinking BC. So these are a bit off, and it is going to be something in the entity extension. So I'll come back to that in a little bit. I'm going to fix these other variables here in calls, and then we'll come back to that. Temp v0 I'm going to call prim index, because that's our convention for that. Hey, guest 73, good to be back. All right. Get rid of as many of these as I can. RS0 looks like it is a legitimate variable. So these are, I always find these tricky. So this is is this some kind of math operator, or is it actually being done this way? This looks like it might be a mod 200. That's what I'm guessing it is. So I'm going to try that, and we'll see if that works out the way that I want. Let's find that. No, not a mod 200. Oh, hex 200. Mod 512. That's pretty close. The move isn't right, but everything else is, and so the move might come from something else, and it may be because of the mistake I have up here, so I'm going to leave that the way that it is. That's the same as mod 512. Oh, the shift right, though. That might be this, yes. So I think that kind of got embedded there. Temp v0_2, that's the other one. So we're going to do that. Yep, there we go. Still have an extra shift. Let's do the plus 300 inline. I usually call this angle. Yep, making it inline made that go away. That's good. So let's rename RS0 angle. Shifts are in modulo. Yeah, they were part of the modulo. What was odd though is if I change this to a plus 300, I get this extra shift. And is that extra shift being thrown away? kind of looks like it. So I'm not sure what. Oh, it's in the branch delay slot. And so I think the additional context when the add is done in the same statement is enough to get rid of that shift in the branch delay slot, because it's known that it's not necessary. It'll never, the combination of these two things will never fall below 0. All right. 38. Try changing this to assigned. There we go. So this is, anytime we have these illegal fields in this entity extension union, that's because M2C couldn't figure out what this is. The first 4 bytes look like first 2 bytes, sorry, of the entity extension look like assigned 16. I'm going to change this back and then do a cast here. So the entity extension will still use illegal, but this time I'll use sign 32, and I'm going to cast this as a entity pointer, and I think I'll be able to figure out what the offsets are then. This may be getting pulled out. I'm going to assume that it's an entity pointer. And not knowing if it's a parent or a child, let's just say it's a parent. Sometimes entities are related in those ways. Sometimes we just call it entity as well. But I'll grab all of those. I don't think these offsets are correct, but hopefully we'll be able to find them. So still not quite right. Let's go back and look at this. And yeah, it might not be, looking at it again, it might not be an entity. So it looks like we have some pointer to unknown 32s. The 84 offset is odd. I'll go with it. 84 is, I'm trying to think of any struct we have that's going to be in the 80s for size. Something that comes to mind. But we can go look in a second. And it looks like all these might be getting pulled out. Up here earlier. We might just be out of order, and that's pretty common. The flags getting ORed is interesting. Uh, 32. There is kind of a standard order that goes with these. I'd rather just get it from, let's do 2 things. We'll look at the one we just decompiled. Look at the order for that. So priority draw mode. Make sure that those are towards the end. Don't have priority. Otherwise, I think I'm going to go grab the PSP version, we have this 819E palette, which is probably unique. Very unique. And this will tell us what the ordering is. Okay, so this is pointing to something. Let's go back and look at since it is in the 80s and not the Bs, let's look at this and see if it might be. Yeah. So if it's in the 80s, it's going to be a value in an entity extension of whatever it's pointing to. And we don't have anything else that's in the 80s, so it probably is the case. So not only do we need to know what the shape of this entity extension is, what type of struct it is, but also the struct of whatever this is pointing to as well. We have a header with all of these, and so our our pointer is going to be at offset 7C80, offset 88. So Ouija table, diplocephalus, something we don't know. The other hint that we have is we have a timer down here on 43. So looking at a timer at offset 7C is probably lick timer. That's something. Now we're back. So yeah, this might be something new. So let's start making an entity extension for it. These are always exciting and fun and prone to unique challenges. All right, so we're going to have, we'll call this ET. Should we make a new, I got rid of all of the other entity extensions of the union. If you're not familiar with C, a union type is somewhat like a struct that you can access different fields, but those fields all start at the same place in memory. And so in this case, for entity extensions, we have 30 or so bytes, maybe 40 bytes of kind of just open space for entities to do with whatever they want. And so to access that easily, we create structs for each of those and then add those structs there. And so they all use the same 40 bytes. You can access those 40 bytes in whatever way you want. Having the structs gives you the correct types. So we're going to have a timer at offset 7C. They start at 7C of the of the entity. That gets us to 8E. We're going to have nothing there that we know of yet. That's going to get us to 8-0, which is also going to be nothing. And 8-4 is going to be nothing. And then 8-8, I'm assuming right now, is going to be an entity. And we can't use the type def. At this point, the type def doesn't exist. So we use struct entity. We could pre-declare this, but we don't. So that's typically what that looks like. So then we access that through this unknown extension. Oh, I copied what I wanted to paste over. And what I want to see here on 43 is, am I doing the right things? I'm not. So this is getting incremented prior to the comparison. And then it's getting loaded again. For us and for our, from the human perspective, those are no different. But from the compiler's perspective, they end up being different. So you have to respect the compiler. There is an interesting difference in where these... Oh no, we just have too many variables. So then let's go look at this. We're going to grab the same field in the struct. And I think I called that entity. And I'm going to choose a field that I know is wrong, just because I want to get the offsets correct. 21. Oh, this was at 84, not 88, so I need to get rid of one of these. And I chose actually a pretty good value. I chose a value at offset 14, or the field at offset 14. I need the field at offset 10. Hitbox offset. Tizik says, I'm thinking about extensions and questions come to mind, like when you allocate memory for an entity struct and extension is a union, but it's also a struct, there must be somewhere code in the game allocating that memory for the extension, right? So C is very loose, fast and loose with how you treat memory. You can cast a pointer to anything as anything else. And unions basically let you do that in a controlled way. So the size of this entity struct, regardless of what is in this ext field, is BC. And we have a lot of checks to make sure that that always remains true, because we need this entity to be of size BC, because we have arrays of these. And an array in C is the size of every element in that array times the number of entries that you have in that array. So we absolutely must have this as BC. That means at most, that entity extension can be B8 minus 7C which I think is 36, why the last B8 is not part of the entity extension, because every time that we've seen it used, it's always a pointer to another entity. But let me make sure that's correct. Yeah, 3C in size. So 3C is 64. Oh, it's 64 minus 4, 60 bytes. So when we look at the entity extension, then we have this giant union. It's huge and ungainly. It shows up at offset 7C, but it has to be 3C. None of these entries in the union can be larger than 3C. And then we do things, like I said, at compile time to verify that these are correctly aligned. So the targets that we're currently compiling for are PlayStation and PSP, which are both 32-bit, so alignment isn't a huge issue there. Work is being done on Saturn as well, which uses all the same stuff. 32-bit alignment there, no issue. But then we have these portable builds that are compiling for 64-bit systems, and if we ever get into the Xbox 360 version, that's 64-bit as well. So now we have pointers and other things that are 64 bits as opposed to 32 bits. And the size of these structs starts changing. And so we have a bunch of static checks then to make sure that the field that we think should be at this offset is the same in all of these different extensions that go into that same type that we expect to be the same. That's a little tricky, and I don't think that they cared necessarily when they were building the different versions of the game, but we have to care because we want to be able to use the same source everywhere. All right, so these look pretty good using hitbox offset here. There's a missing instruction in the middle. The store word. Fix that in a second. This one can go away now, the unknown 32s. My guess is that this is facing left down here. Oh, maybe not. We'll see. Looks like it. What's it? Offset 6C. Working on different parts of the game, you get familiar with, this shows up as opacity. That can't be right. So something else is going on here that I have wrong. We'll figure it out in a little bit. So the next thing is trying to figure out what the ordering of those fields is. I think I might have all these gone to. We have one extra thing on the stack. It is possible often we have a variable here, but it looks like this is just being assigned directly to prim index in the entity, and then it's checked again by reading it back. It's like it's our stack correct. All right, now I'm going to get the ordering, and I'm going to use M2C for the ordering. So we have flags are facing left, which I believe is wrong. Unknown 5A. Anim set. Palette anim. Draw mode, draw flags, hitbox. All right, so let's look at that. Yeah, so this is going to 84 and 8C. So it's going to a different entity extension. Oh, and this is at 8C. So let's throw a few more spacers in there. I'm going to keep the illegal extension there. So illegal is a union that we use basically with a bunch of arrays in it of various types, and then we can kind of dial in where those offsets are supposed to be and then build an entity extension based on those. It's a little easier than trying to come up with the entity extension first. Okay, so this compiles to the right thing, but I do need to get rid of the illegal extension. So we have, I'm going to mark what the offsets are here. So this is 84. This one is 88. And this one is 8C. And then I'm going to go back and again, kind of look for other entity extensions that have something that looks like a position X, position Y, and facing left at those offsets. And this is kind of trial and error. If there's something that exists already, great. If we have to create another one, that's fine as well. This is interesting. This doesn't have the timer, but it does have a parent pointer at the right location. Not seen anything that looks like it has an X coordinate at 84 though. The other thing I want to do, I don't see anything obvious. Is see if we can tell where this is being used. kind of X. Let's see. Something without 0 in front of it, and then X. We do have one with pause X. But I need it as a 32-bit value. There's acceleration X. Let's look at those two. X. Yeah. So it's not this one. And then acceleration X. Not boat related. Not boat related. Sorry. Poking around entity extensions. I don't see anything that looks like it's related. I'm going to look for where this function is and see who references it. Where is it in relation to other things? And if we could tell anything from that. Unfortunately, nobody references it. This actually may be related to Shaft's orb. So this might be something I'm looking for anyway. We see it show up. Oh no, it's within the Richter weapon crashes. So it's probably one of the crashes. Let's look at where Vibhuti and Rebound Stone are, and what comes between that. I don't know where these are going to show up. So, what comes after Vibhuti? Decreased brightness. Not interesting. Agunya. But I think we have Agunya. Is there anything else interesting? It's possible as well that there are there item crashes that Richter can do, but look at this. I think this might just not be in my context. We have our Rand mod 512 plus 300. So it looks like this is the item crash, Vibhuti crash cloud. So I'm not sure why this didn't match. It looks pretty similar. It doesn't. Yeah, it has most of this. But for whatever reason, it's not at least 90% similar. And the 90% comes from the opcodes. Not necessarily the immediate values. So I'm a little surprised that this didn't match. I'll grab this. I'm going to look at duplicates again. Oh, where's duplicates? Yeah, it's not similar enough. I don't see really anything that that different is terribly different. So we're working on this one. So I need to go back through and make sure that I have the Vibhuti crash cloud and crash entity extensions in my context. It's been a while since I've updated my context, so it is possible that I didn't have these in there. We can get rid of this entity extension as well. So here we see one of those cases where we're trying to align fields appropriately on platforms of different size. Oh, I do have these in here. Huh. So let's fix those. For some reason, this function, they used the name entity instead of self. That should not be allowed. And so they called this unknown 7C instead of timer. There's a ton of these that have timer. I think I'm going to go and rename that. But I think that's probably it. There's a little bit of a difference. So this must not be... they must... no, that's the way it was. Okay, never mind. They're doing it else down here. I'll do the same thing. I like the idiom of destroy entity and then return. That's used pretty frequently, but I don't mind the else. I think that'll match. I'm really surprised. We could do a diff and see what how those differ. Hey Pepika, Giga Chad, good to have you back. So we need to do a couple things. We need to add a symbol for this. I probably should make sure that it works on the PlayStation. It looks good. 10 is from here. Alec primitive. We'll compile it first with the automatic name. That worked fine, and now we'll give it a better name. If I had that entity dispatch table created already, I wouldn't have to add this to the symbol table here. But since I don't, I do need to create an entry for it here. We're going to prefix it with B06 to avoid a name collision. So C didn't have namespaces, so it's pretty common to prefix names of things. if you've ever done any Mac programming, you'll notice all the Objective-C Cocoa stuff starts with NS. That's because the SDKs were originally written in C, NS standing for Next Step, which was the operating system Mac OS was based on. So I think that's it. I am going to go back to that file though. So here we have this. This is our entity dispatch table, depending on the entity ID. We should actually compare this to the Richter entity dispatch table. But depending on the ID of each entity, we'll go through, look up the, use that as an index into this table, and that's how we find the function that gets called. But we should be able to find all of the other Richter symbols in here. What should also be in here, and my guess was that it would be at the end, but seeing that Richter goes almost all the way to the end, maybe not. The shaft orb should be in here as well. Let's try to find the Richter entity table. Right, so what we should see, I'm hoping, is where's Blink White? That these tables line up. I can get them to line up myself. How do I, what is it, VLOC? Come on. My Vim is failing me. Scroll lock, scroll bind. And so are these, so player Blink White, subweapon crash particles, is that it? Yes. What if we go down? Crash rebound stone? Yes. Well, that didn't scroll bind. I'm looking for a Gunya. Let's go down here. So I want to figure out where this diverges. And so we have hit by holy, hit by dark. I'm guessing this is stopwatch. This is different. So these bottom four may or may not be related. Teleport we don't have, or we shouldn't have, because it doesn't make sense. Richter can't teleport. And then near the top, we have Entity Factory, this price, smoke, etc., etc. So my guess is that the shaft orb is one of these bottom functions. So I think that's what we'll do tomorrow, is go through. I'll try tonight to map these other ones. I might reduce the threshold of the duplicates report. Let's do that to 80%. See if those show up in the duplicates report. and maybe there's more that we can find. I'm really surprised that that this one didn't fall within the 90% threshold. We should have this report in 10 seconds. Nice to have progress here. Beggars can't be choosers. All right, let's look at that. So the ones we expect. Let's see if the booty BIH BIB. So yeah, the Vibhuti ones are showing up now. So it is possible that I can get some more symbols and then figure out what those other ones are. So anyway, we got another one in the can, 2 in the can. Only 126 more to go, something like that. We're working on Richter, the Richter boss for Castlevania Symphony on the Night. You can go to soten.z.dev to learn more. And I'll be back tomorrow. Catch y'all later. Adios.